Hello, there are more seats here, so some brave people can come over to this front seat. Yeah, we couldn't get a really high quality microphone, as you know already. We send a message to everyone, so we put this down at the last minute, so it's not the perfect quality. So so please, I don't know. So if getting closer is maybe better to listen to the people's talk. And then second thing is for the panel, any question if you have, because this is the only single microphone we have tonight. Unfortunately, we send everybody, we call to the PA hire everywhere, but this is the only one. So if you have a question, so come close to the stage and then ask a question really loudly. Then it's not difficult. Okay. Thank you so much for coming tonight. And then as I sent out the posted everywhere, we are actually overbooking, 200% overbooking, which means 3% people booked for this tonight, for this event. So actually still people are sending me an email about it, so more people I guess are coming. So, and then it's quite crowded, but hope you understand. And then so we have 90 confirmed people, and then 30 people in the standby, and then 130 people in the wait list. So it's quite a lot of people really interested in tonight's event. And then, and sorry for all the confusion, not sending a confirmation email right away. And then thanks for being patient with me. Yeah, and then most of people got a name badge, I guess. And then this one is manual work. So I spent 3 hours yesterday type everybody's name, the one by one. So it makes me really feel like a Christmas party. And then another thing is important. So restroom for this event is you have to go all the way this direction and then take a left. Yeah. Yeah. And then we will start with the welcoming message from tonight's venue, drink and food sponsor, the HSBC. Then I will share the agenda for the event and talk. All the talks will start. And then here's the Kashalia. She's the head of the FinTech partnership at HSBC.
Thank you. Thanks very much. Hello, can you hear me? Okay. Well, so a little bit about myself. I'm Kashalia Somasundram. I head up FinTech partnership for HSBC across the corporate and institutional banking space. So thank you very much, all of you, for coming today, and I can see a fairly big turnout. I think I've been told that there are people from various facets, so some blockchain DLT companies, some banks, and Hyperledger.
We've got everybody in London here.
We got pretty much everybody. Okay, that's great. So my role effectively is about predominantly fintech partnership, but I also cover third-party partnerships. What I mean by that is that we've got a number of sort of high-level strategic kind of partnership that you're looking at with the likes of Google, Amazon, Facebook, but also equally at the growth equity stage as well. So some of the companies that we've invested in, and equally the ones that we are partnering or looking to partner with in the sort of early stage companies. So up until recently, I was also part of the Innovation Investments team, which is a corporate venture capital arm of HSBC. So investing in early stage startups. So I recognize a number of you, having spoken to a few in that regard. But just about 3 months ago, I took on this role to sort of lead the partnership angle. And essentially what that means is that wherever there is an opportunity, and it can be blockchain distributed ledger, it can be any facets in terms of emerging new technology or even current technology, where we want to actually deepen our partnership across the group, so more than one product line or business line, I kind of try and prioritize that and work with the businesses and the external community to sort of accelerate and catalyze. So that's really my role. And as I said, thank you to Easel and the team and Barry, who's here, for organizing this event. So I can't imagine how much of admin work has gone behind it, so thank you again. And thank you all for coming. I want to also give a special thank you to sort of Hyperledger community. I think I'm very impressed by what's been done and in terms of contribution. particularly to the open sourcing. So I think it's really drawn a lot of interested parties to this forum. And as you know, blockchain has been very topical and continues to be. So quite interested in the space. And apart from that, I'm not going to let you stop you from sort of socializing, so because I think it's a good opportunity to network as well. So once again, thank you. And if you have any questions, do reach out to me on anything. And sorry, I should have started by saying one housekeeping issue on health and safety. Should the fire alarm go off, please do not use the lifts. You can go down this dome. So there are 2 doors. There's one and the second. And then take your right and go down the stairs. I hope that doesn't happen tonight, but just in case, there's one last bit on my side. Okay, thank you very much. Enjoy yourselves. Thank you.
Okay, so this is our venue sponsor. And then we got lots of drinks, and then the really nice venue with the view. And then, thank you so much. Yeah, and then, so tonight, in the first talk, we will celebrate the R3 Corda, the open source, to the Hyperledger project. And then, so sharing the more details of the agenda, second. So, welcome first. Yeah, and then the first talk will start 7 minutes ago, which is the R3 Corda open source initiative. We don't have a screen. It's gonna happen. So first talk is the R3 Corda open source initiative, and then so it will be the technical deep down of the R3 Corda code, and then we have 3 core engineers from the R3, Mike Hahn, James Carlyle, and Joel. Joel. Okay, Joel. So he joined really last minute, so I have an excuse. So, and then 7:10 we will have a Q&A break. And then we will have a 20 minutes of Q&A session. So we have a 1 hour to learn about the R3 Corda for tonight. And then 7:30 we have a 2 mini talks. First talk is the 2 minute talks and the fireside chat, which is a panel discussion. So and then 7:30 to 7:55 is the mini talk, which is the HSBC Corda demo presentation. And then 7:55 to 8:20 is the mini talk 2. It's a Hyperledger Fabric, the version 1.0. It's a preview with the John McLean, right? So I guess it used to be Anthony, but it changed to the John McLean. So from the IBM. And then we have a panel discussion from the 8:30 to 9:10. So I posted at 9 p.m. It's ending, but 10 minutes little more we're going to spend. And then after then this venue is open until 10:30, so you can stay and drink and then socializing. I don't know why left, but I guess so. The first talk, Michael, please come to set up your computer. Yeah. Yeah, so I'm going to, yeah, so I can see it, so you have to introduce yourself. Sorry, I can introduce myself.
Start. Hi everyone, so thanks for coming, and we're going to talk a little bit about Corda. And we're going to, I hope, get into some code and try and think through some of the design decisions that have influenced Corda and some of the requirements that have driven Corda to be what it is today. So I'm going to spend literally 60 seconds talking about R3, and give a very quick introduction, and then I'll hand over to Mike for the tech deep dive. No, that's not. So I'm not really going to read these slides, but R3 is a consortium that's founded just over a year ago, and its goal was to help banks, predominantly, initially at least banks, understand distributed ledger technology and how to use it. And R3 is trying to solve two really hard problems. And the first hard problem is collaboration. So I guess it goes without saying that distributed ledger implementation, particularly in corporate settings, needs collaboration. And it needs collaboration amongst parties who typically and normally have different economic interests, and they're not very good at collaborating. They're much better at competing with each other. And so the trick that R3 is pulling off is bringing competitive parties together and saying to them and helping them understand that at some base layer they have to collaborate. They have to collaborate to get distributed ledger technology implemented. And the message is that competition will carry on, of course, but the base layer enables collaboration at higher levels. The base layer, collaboration at the base layer enables competition at higher levels. And the other really hard thing that R3 is trying to solve is the idea of how to commercialize distributed ledgers. And I think R3 has a very strong focus, obviously, in banking, but banks have enormously complex infrastructures and enormously complex operating models. And in order to really realize the benefits of distributed ledgers, the operating models need to change. And so it requires large-scale structural change within organizations, and that takes time. But that is absolutely necessary in order to really achieve the benefits that some of the market viewers, some of the consultancies observe. So organizations like McKinsey have suggested that I think in 4 key use cases, there are probably $80 billion worth of sort of redundant operational processes and that stem from breaks, reconciliation, and endless checking that a distributed ledger could definitely help with. So another point that Paul Vigner from the Wall Street Journal observed was that most startups, I guess they have an inspiration for a product and they market it and sell it, or try and sell it, and then they refine it. And R3 is very much a consortium that tries to listen to the membership and tries to encourage collaboration. And we do this in many different ways. But we are trying to build distributed ledgers together. Just a map of the R3 membership. So it's a very diverse group of organizations spread around the world. So we struggle with time zones and things, but we have spent a year trying to figure out how to get organizations to collaborate together and how to share information. So we have a preference, for example, that intellectual property is shared across the consortium so that all participants can benefit from it. And we run a lot of infrastructure, things like wikis, in order to help that sharing. And final slide from me. So deployment, certainly in financial markets, is going to be really hard, probably for these reasons. Issues of collaboration, governance, technology, regulation, standards. And what we're trying to do is build a bridge. So over at this end, simple proofs of concept within an organization, or perhaps just with pairs of organizations, that's easy. But we have to take care of so many hidden aspects. And we have to, the way I guess that distributed ledgers work means that there will be regulatory impact. And we have to bring the regulators, and we have to bring the legal frameworks, the judicial systems with us. We have to be able to describe how we're going to operate distributed ledgers within a legal framework and so on. And so all of that activity does take time. And then, I have no idea what this is going on. We run projects. There's nothing more to say. I need to say I think that there's a sort of evolution with these projects, that some are becoming more focused on regional aspects as the players get more sophisticated. And then the other focus or trend, I suppose, is that certain aspects, like representing cash on the ledger, take time. They take different approaches. We have to experiment with different ways of doing this in order to validate them and prove the right approach. So some of these projects that we're working on, we're actually now on our third iteration. And as I said, the challenge is commercialization. So for all of these projects, the end goal, of course, is to commercialize them. Okay, thank you very much.
All right, okay. So I think a few of you already know who I am, so I'll keep the intro short. My name is Mike. I'm the Corda lead platform engineer, so I did a lot of the design and coding work and hiring the team. And I spent 5 years as a Bitcoin developer working with the excellent Gary and Jim, wherever Jim is. And yeah, we built Bitcoin wallets together for 5 years, and now here we are at the top of the skyscraper. That's a journey all by itself. And I also spent nearly 8 years at Google, where I was a senior software engineer there. And now I've spent a year at R3. So, Corda, the Empire Strikes Back, hence. now you know I was a Bitcoin developer, hence the name. Okay, we're going to cover some stuff, the interesting features in Corda, and some unusual design decisions, and then briefly talk about the next steps. You know what, let's go all the way to the top and see if we... This is Apple's PDF viewer not doing... Oh, there we go. Right, stuff we'll cover. Okay. That's us, that's the little team in our office cutting the Corda cake to celebrate the open source release. We open sourced it last week, not because it's finished, far from it, but because it's now done enough, the design is baked enough that like the sort of the vision and direction is clear and people could meaningfully contribute, meaningfully evaluate the design. It's not ready for production yet, and we'll talk about how we'll get there. Right, how does it work? So here are the basics you must know. If you forget everything else about Corda, please don't forget these. There's no blockchains and there's no mining, right? This is the most basic thing. This is, of course, in common with some other post-Ethereum systems, you might say. It's designed for permission networks, but of course you can run a Corda network where you give permission to anyone who applies, of course. So if you wanted to run a kind of semi-open network, you need to give people an identity of some sort, but that could just be an email address if you wanted a really public network. R3 will run a network which is significantly, you have to sign contracts and agree not to be naughty and things if you want to get on that network. It's primarily a JVM-based platform. It's both implemented in a language called Kotlin, which is basically a better Java. It's sort of simplified Scala, you could also think of it. And we also use a JVM as our smart contract sandbox, actually a derivative of the JVM, not a real one, of course. Well, not like a full-blown one, and we'll talk about that a bit later. There's an open source reference implementation, and we have a design document, which is a technical white paper. That's a lightweight 55 pages. So if you are having sleeping problems, I recommend putting that under your pillow. I wrote it, so you can be assured that it will put you to sleep really fast. Okay, so James, did the diagrams really get lost when I sent you the tech? Okay, there was supposed to be a diagram on this slide, but somewhere PowerPoint handled it, so we'll have to do a text. So we start with a Bitcoin-inspired transaction structure, right? Corda uses what is sometimes called the UTXO model. It isn't a global computer. It implements like a database, in effect. And as a result, our smart contracts don't have variables or anything like that. They just give you a thumbs up or thumbs down on a transaction. Both inputs and outputs have associated smart contracts, and they all run. So it's a little different to Bitcoin in that respect. The signatures are external to the transaction data, so sort of like Bitcoin post-segregated witness. And you can, because transactions in Corda can do lots of different things, not just move money around, there's this notion, we've added this notion called command, which sort of parameterizes transactions and tells the smart contracts what the transaction is supposed to be doing if it's not completely obvious just by comparing the inputs and the outputs. And the Corda ledger consists of these things called states, which are pieces of data. And states are immutable, so you can only mark them as used and add new states. So the ledger effectively grows forever unless you choose to throw away the old consumed states. And by the way, I should have mentioned this. Throughout this talk, I'm going to discuss things which are implemented and things which are not yet. I'm going to be implemented. The things which are not yet will be marked with an asterisk. So when you see an asterisk, that means it's on the roadmap to implement next year, but we haven't done it yet. So key randomization is a privacy technique, right, with a way to link those anonymized transactions back to identities. Okay. There's also an Explorer app. This is kind of what it looks like. I got a little video of this as well. You know what, actually, I wonder if I can show a little video. Yeah. So the Explorer app links to a node and is intended to allow you to administer it and also check it out. So you can see transactions here of cash. You can see the commands on the right-hand side, move or issue or exit, because you can, of course, there's no cryptocurrency in Corda, so you can issue dollars or pounds that are backed by an issuer like HSBC. There's a sort of map showing you activity between the nodes. These are this is activity from the perspective of the node you're logged into, judging, and it's based on the signatures actually of transactions that are being processed. So it's showing economic activity. It's not actually a God view, even though it may look like it is. So you can see here that this transaction has some inputs and it has some outputs, and then there's some signatures at the bottom. So if those of you are familiar with Bitcoin, this will all look pretty standard. We use, as you can see, the Explorer app uses identicons to visually represent transaction hashes to make them a bit easier to separate. There's fiddly bits. So a part of Corda is that it's designed for people who don't break the law, and as a result, transactions and smart contracts are linked to legal texts. How do you implement that? Well, transactions can have these attachments. You can attach zip files to transactions. These are deduplicated across the wire, so they exist on the ledger, they're shared data, but they don't get sent more than once, and you can put all kinds of things in them. Most obviously, bytecode that defines smart contracts. So unlike Bitcoin, we don't embed the bytecode into the transaction itself. It sort of comes along for the ride in an attachment, and you can put static reference data like holiday calendars and other things you want to do with financial logic there, identity certificates, other things. You could even put PowerPoints in them. I'm thinking about imposing a rule that you can't do that, just to stop people like uploading videos and stuff into the shared ledger. Possible, technically, but abusive. You can cascade attachments together, and they can't overlap, so they create a little per transaction file system, and this is how you can do things like attach holiday calendars and currency data and so on to a transaction. Transactions are structured as a Merkle tree, so you can selectively reveal different parts of a transaction if you want to, and you can blind sign a transaction by requesting a partial tree and then signing the root hash, right? And at the moment, the Corda design is mostly done, but there are still things which we might change. States are currently arbitrary object graphs. So unlike in Ethereum, where a smart contract has a key value store, you can actually represent you can have objects that point to each other and things like that. And the reason that this is allowed currently, and I go back and forth on whether we'll keep this or whether we'll restrict it before we go final, is someone told me that some banks have got FPML structures that represent deals which have to repeat data over and over again, and it turns into gigabytes of XML just because the format couldn't have pointers backwards, which seemed a bit silly. But we may nail this down a bit so you can't actually do arbitrary object graphs in the future. We'll see. Part of the reason that we've been prototyping this year, and part of the work we've been doing with Corda, is to develop a proof of concept and develop apps to find out what features people need and what they don't, because you can ask them. You can ask people, but some people don't always know. We also have this thing called encumbrances. This is in fact a feature by James. And this allows you to require that if one state is consumed, the other one must also be consumed, and because states trigger contract logic, this allows you to compose contract logic. This is another area that's described in the white paper, and we might tweak a bit. I forgot to start my stopwatch, sorry about that. So we've got a bunch of unusual design decisions in Corda, which make it a little bit different to what else is out there. So one is there's no global broadcast anywhere. Transactions are resolved lazily, so when you validate a transaction, you sort of download all of the dependencies and validate them too. For those of you who are familiar with the Bitcoin protocol, maybe it's just me, Gary, and Jim, I don't know. But if you took out block broadcast and you took out transaction broadcast from Bitcoin and you sent a node a transaction, it would notice that it didn't know the dependencies and it would ask you for them, and there would be a back and forth conversation where you upload all of the dependency graph back to the Coinbase transactions, right? And it would validate them all. And that's how Corda works by default. And this has a few consequences. It has a few interesting consequences. One is that denial of service handling becomes dramatically simpler because you know who you're talking to. There's no point where nodes are relaying data for other nodes. Another one is you can do bulk data imports silently. Right, so if you have millions and millions of customers like HSBC and you decide one day to put all of that onto the shared ledger, you can convert it all to Corda format in an overnight batch job and not be limited by the rate at which you can upload data to the network, because that data will be pulled across the network on demand when it is necessary, right? And then other nodes will store it, but they won't, you know, that you don't have to send it to them ahead of time. But it has some, you know, it's not all upsides, right? It has some other consequences as well. So one is that you must specify where data is sent. If you don't send it everywhere, then at some point you have to tell the system where it goes. And so that adds a bit of thinking to the data model. You suddenly have to think about this. So the other one is that sometimes you don't know who the data should go to. And as a result, one of the things we're going to add next year is we're going to add back a sort of partial gossip network, actually a sort of propagate through the invitation tree to preserve this nice denial of service handling property. But that's covered in the design doc. Okay, so how does this work? Well, there's this peer-to-peer network, and all communication is bidirectional. So nodes always says, I used to be a Gmail engineer. I worked on Gmail for several years on spam filters. So the Corda network bears a strong resemblance to the email network, and that's not really a coincidence, right? Messages travel between identified nodes, and messages are organized into what we call flows. And a flow is actually, it's not a vague concept. A flow is actually a feature the platform provides, and it gives you a kind of Uber thread that can't be killed, right? Even if you restart, well, it can be killed, of course, but even if you restart the process, it will carry on just where it left off. Behind the scenes, this is done using a fiber bytecode rewriting engine, so it actually rewrites your code that is nice and straightforward into a checkpointing state machine that checkpoints to a database. And in this flow, you specify, this is at the point inside your flow code, this is where you specify where data goes, and you specify the sequence of operations. And this is one of the first things we built, actually, one of the first things I built a year ago when we first started writing Corda, because I knew from experience with Bitcoin programming, in the old Bitcoin J days, I didn't mention the work I did on Bitcoin was that I developed the primary Java implementation, like the Java client library for it, basically, Java implementation of the protocol. And for anything complicated, you end up with these quite sophisticated state machines where you're going back and forth and you're swapping messages, and I sign and you sign and you send the signature back to me, and if anything goes wrong, there's error handling and you have to checkpoint to disk, so if you restart halfway through, you don't lose money, and it gets quite complicated. And so the flow system is a way to automate all of that, right? And if you deliver a message to an identity and that node owned by that identity is offline, messages buffer up on disk until they come back, right? There's like a retry, automatic retry of delivery, so you can take your node down for restart or upgrade, and it's fine. You don't have to worry about like super high uptime, because you can just bring it back and everyone else will redeliver their messages for you. Flows can not only interact with machines, the intention is that they can also interact with people, and this is why it's so important that these threads, and they are threads from the programmer's perspective, can last for days. Because, you know, if you stop and you block on getting a response from a person, and that person is sick or it's a weekend, then, you know, the state of that thread is going to survive for a long time. So that's why we have this sort of, the ability to checkpoint this stuff, including the contents of the stack frames and reachable objects to the database, right? And the underlying protocol is AMQP plus TLS, and the Corda protocol is basically based on message queues. Okay. Oh, and they also do progress tracking, and every node has a relational database as well. We'll talk more about that in a second. Flows can evoke subflows, and there's a standard library of flows for common tasks. So flows are actually a fairly core concept in Corda, actually, because you need to coordinate what's going on. And for example, there's a flow which I can show you in a second, actually. I don't know if you guys can see that. So this is what, I mentioned Corda is written in Kotlin. You don't have to write code in Kotlin to use it, by the way. You can use Java or really any JVM language that compiles to regular bytecode. But you can see here that we start here, and you know, we receive and check a proposed transaction, like here. So we're sending the, this is a flow which implements trading, atomic swap of assets on the ledger. I have cash, you have barrels of oil, commercial paper, whatever, and we want to atomically trade on the ledger. So to do that, we build a single transaction together that we both sign, right? So there's no point at which you can get stuck. And as you can see, it's sort of type safe. We say we are going to send a hello message, and then we receive a signed transaction, and the signed transaction is potentially untrustworthy data, actually. So I don't know if I can do this. Yeah, so if we get the explicit type here, you can see this is marked as untrustworthy to remind you to check it for security issues. And then you can see down here, there's a subflow. At any point, right, if it stops here waiting for a message to send and receive, the thread is suspended to the database and you can carry on. Okay. SQL support, right. So I don't know, can you put your hands up if you've actually attempted to build a real blockchain database that like has real users? A few. Yeah. So it's pain in the ass, isn't it? I've done this several times, and one of the problems you get is that like the data model these platforms use isn't really that easy to integrate with any existing app, right? In particular, most apps out there today, most business apps use the relational database model, which is a very successful one. They have tables, they have lots of data in tables, but then you have to throw that all away when you start using Ethereum or Bitcoin or indeed Hyperledger or whatever. Sorry, Fabric. Please catch me if I do that again. The trademark lawyers will whack me around the head. Corda allows you to annotate your states with JPA, Java Persistence Architecture annotations. These states are, when relevant to your node, fed through an object relational mapper, write only. Right? The Corda itself doesn't care about these tables, but application developers can find them pretty useful. The data comes in, it's got your public keys involved, so it's about you, it gets fed through, and then you can access it with JDBC. So any existing app, and you can actually create your own tables, of course, in this database. Corda has an embedded relational database called H2, and future versions of the software will let you use more serious adult databases, you might say. Actually, H2 is very good, but it's an embedded database. And of course, you can put your own private data in there, and then do joins to link it with the public ledger. So it's very common in Corda apps that state schemas have opaque slots that the smart contracts don't care about, and nothing in the Corda system or the global ledger actually cares about what's in these slots. But they're there for you to put encrypted join keys. So you can easily merge private customer notes and private data with stuff that's in the ledger. And this has been a tremendously popular feature. We were implementing this, we were getting people like saying, we want it now. We said it's not finished, and they were like, we don't care. We were starting on proof of concept and we want it right now. So we were sending people like half-baked versions of this. But it's very popular. And you can see here, this is IntelliJ connected to one of the Corda nodes, and you can see you have transaction IDs, but also you've got like currency codes and issuer keys and other things there, right? And you can pick the schemas. There's also support for schema versioning. So just because apps on the global ledger can obviously evolve, and just because they can evolve doesn't mean your app will like atomically evolve. Like everyone's app would have to evolve at the same time simultaneously globally, right? If we didn't have any support for schema versioning, and that would make deployment impossible. So you can actually version these schemas. All right, no trees and consensus. So there's no blockchain, there's no mining. We have pluggable consensus algorithms instead. This is not a hedge that we don't want to do the work. We have actual implementations as well. But the thing is, computer scientists keep coming up with very nice new consensus algorithms that have better and better trade-offs, and we didn't want to like tie the system to a single one. And so we have a bunch of notary implementations, and notary is a logical concept, right? Notaries are usually made up of many computers run by different people around the world. We have one that runs on a single machine. That's useful for local testing and development work, of course. We also have one that uses Raft. Raft is not a Byzantine fault-tolerant protocol, but it is very fast. So if you have a ledger, and then each state points to the notary that controls it. So you can have multiple different notaries, competing notaries, even on the same network, right? So for example, if you have a bunch of banks and they're all on the same island in the middle of London, then maybe they're not worried about double spending each other because they're big and regulated and the FCA is just down the road. So then you want performance, right? Low latency and performance, and Raft gives you that. And one of our projects next year is to take the BFT Smart library, which is one of the very few actually solid, or it claims claims to be a solid implementation of a BFT consensus algorithm, and we'll be building a notary based on that as well. Okay, so Ethereum has the EVM, Bitcoin doesn't even have a name, it's just Bitcoin script, little bytecode language, Hyperledger, you could, Fabric, you publish source code and it goes into a Docker container. Corda, it has a virtual machine. It's a stripped down JVM. Actually, most of the stripping down is done with bytecode analysis and rewriting when the code is first accessed. But we also have we also need to patch the JVM itself as well in some small ways. The goal is to make it deterministic, right? And the reason we use the JVM and not the EVM or design our own is because the JVM has really good tools, it has good languages. You can write smart contract code for Corda in like Haskell or Java or Kotlin or Scala or you know, whatever you want. There are even academic languages like Wiley is an interesting one that has formal methods integrated, and there's a whole bunch of other things. So we get good debugging support and high-performance JIT compilers and all kinds of stuff. So there's tons of reasons to use a solid production JIT virtual machine. Of course, it's not usable out of the box because we need to get rid of a lot of stuff. So there's no threading, there's no GC finalizers because that would run on a separate thread. No access to external data, of course, that wouldn't be deterministic at all. If you want external data, you attach it. We have to modify object.hash code. There's no native code allowed, of course. The bytecode is rewritten to account for expensive opcodes. We adjust exception handlers to prevent you making an unkillable thread. We enforce strict floating point everywhere. There's no invoke dynamic. The class library is also rewritten as well. And what you get is a sort of sandbox where you can't make a non-deterministic computation. And a lot of this is implemented. It's not integrated into the code base yet. That's one of the things that I'll be working on in January and February, basically. Final thing, okay, client RPC. We developed a little RPC stack. Fabric uses gRPC, which is great. Protocol buffers, I'm all for it. We wanted to do a little bit different. This is very small, right? This isn't a big project by any means. It's only 800 lines of Kotlin. It's an RPC stack that operates over message queues. So it has a few unusual features. One of them is that it integrates with ReactiveX. So can you put your hands up if you're familiar with ReactiveX and RX and reactive programming and stuff? Oh, okay, not that many. So an observable is an object that represents like a stream of observations, and you can subscribe to them, right? So it's like a callback abstraction. But you also have this huge library of operators that can transform these pipelines. And you can do like pipeline-oriented programming with these. So you can receive a stream of events, transform them, filter them, do all kinds of interesting things. There's like 100 operators or something. It's a really giant standard library. And there's RX implementations in all kinds of languages. And our RPC stack, you can actually send observables over the wire. So this makes it very easy. If you have something like REST API, sending a message and getting one response is quite easy, but if you want to send a message and get a constant stream of responses, especially if you want to deal with things like back pressure, like if you're not processing them fast enough and you want that to propagate through to the server, it's hard work. But message queuing systems handle all this for you, so we built on top of that. Back pressure management needs to be switched on, right? Both the RX framework and we're using Apache Artemis as a broker, support back pressure management. We just haven't wired them together yet. And then finally, there's a little client library which has reactive collections, so you can connect. You do an RPC, you get a snapshot of a data structure, a stream of changes to it. Then we provide a little client library that joins them back together, and you can connect those collections straight through to a user interface if you're using JavaFX, which we do for the Explorer app. And this makes it very easy, very functional way of getting data from the node into your app and onto the screen in such a way that it is always live, and you don't really have to think about it. We also have the web surface. Stand up, take a bow. So, developing a experimental domain-specific language for encoding of financial contracts. This is based on a paper by a bunch of researchers from Microsoft Research, and in fact, Surface visited them today? Yesterday? Yesterday, yeah. One of those guys is actually one of the fathers of Haskell, you might say, Simon Peyton-Jones, and he wrote a paper with a bunch of others 15 years ago on how to use functional programming in the financial context to do like valuation of deals and things, right? And some of the ideas in here were taken into this experimental domain-specific language, and you can see there's like a bunch of actions in this arrangement. We use the term arrangement here rather than contracts to avoid confusing different but related concepts. An arrangement is one of these DSL things, and it creates a smart contract. And then you can see there's banks, and they have options of things they can do with constraints on the conditions, and then the outputs. And so it's a very lightweight, very simple way of expressing what can be done. And this is still experimental. The language is still evolving, but you can kind of see how it works. And there's tons more. Yeah, you can read the screen faster than I can say it. So some stuff. 5, 4, 3, 2, 1. I don't want to keep everyone from the drinks. That's the thing. Okay, next steps. 4 S's. Okay, so until now the Corda philosophy has been experimentation, design, study. Now we're going to do serialization, security, scalability, and finishing the features. That's the 4 S's. Because these are our priorities for next year. What? 10 minutes. Okay, that includes Q&A?
Oh, you got 20 minutes.
Oh, okay, loads. Oh, so I'm nearly finished. Great, so we'll finish early. Okay. Corda today is riddled with security holes that we know all about. The first year of work was built on building proof of concepts, talking to the members, talking to the architects at the banks, and there were a lot of them, so there was a lot of talking. Finding out what they valued, what they didn't. Trying to see if we could solve problems like no global broadcast, pluggable notaries, other things that we thought would be nice, but we weren't sure if we could actually build, and proving out that we could come up with data models that allowed that. But it's not production-ready code, right? What we did do, though, is we noted down while we were writing the code all the places where we knew we would have to revisit it and fix things. So locking down security is happening now. This is one of the things on the way to having a test network, right? Currently, Corda's serialization protocol is like auto-generated and ad hoc, so it's not something you could specify in a formal standards document, other than the fact that we're building on top of AMQP. So picking a final serialization format and integrating it is one of those other things too. We left this till last because really serialization is boring. You know, it's a bike shed. Everyone has an opinion on it. There's lots of ways to do it, and they're all pretty similar to each other. And it's not a hard. It's hard in the sense that it's a lot of work, but it's not a hard feature, as in something where there's novel design work to be done. And then finally, scalability. It's very hard to compare Corda's scalability to other systems, right? Because there's no global broadcast, you can't take a Corda network and say how many transactions per second it can do, right? Because load doesn't globally propagate. And so, as part of, we've actually written load testing code, and there's some missing features in the Vault. We used to call it the wallet, just like Bitcoin developers do, but it was a bit folksy for banks, so we called it the Vault, which sounds a lot stronger. We need some features in there before we can really drive the whole network like as hard as we can. And what we'll find then is it's slow, of course, because we haven't optimized it at all. And so some of the work next year is going to be scalability. And then finally, yeah, the little asterisks in this presentation, we'll be removing them. One last thing, specifically on privacy and scalability. So we have a design for like whole. We use X509 PKIX for identity management, or the base layer of identity, I should say. The identity is a huge topic, of course, and the base Corda layer only establishes like legal name to node mappings in effect, and then you can build much more sophisticated notions of identity on top of that. So we're going to build out the rest of that, and at that point you can start randomizing the keys used in transactions. So what that means is you get a Corda transaction, you won't know who's involved. Even though you may have downloaded it as part of verifying the integrity of the ledger, it's like a Bitcoin or a transaction. You only see keys and you don't know who owns them. We're also doing some interesting privacy research. It's in the prototype phase, and I'd love to talk to you about it. But there's a little bit more to do there before we are sure that we can ship it. And we don't want to talk about things that might not make it to production. But this is going to be really good when we get it out there. And then I mentioned the load testing and stuff already. And this is our goal, right? This is software, so we'll probably miss it, but we need to have a goal anyway. End of Q3 2017, API and protocol stability. So we won't have every feature you might want from a fully production piece of software. There'll be like admin features that we'll still be adding and things. But this is the point at which your apps won't break anymore, and the network won't kick you off if you don't upgrade, within reason, of course. And at this point, this is when we can start doing pilot networks and actually taking things through to production. And that's it. That's the last slide. That's the end of the presentation. Thank you very much for listening. I don't know if we can really fill 20 minutes with questions, can we?
Depends on the questions.
Yeah. I can give long, winding answers. How brilliant. Does anyone have any questions?
What's it?
Oh, yes. Okay, too. Great. Okay, you first.
It's probably a simple question, but it's just about security. Why
Yeah.
not security first, rather than like retrofit it back into the code? Because obviously you're dealing with financial instruments or financial assets.
Yeah, perfectly reasonable question that I was 100% expecting to get asked. You can also say, why not scalability first, right? Or why not, like full robustness, or have an admin interface first and other things. So you can prioritize these things however you want. For example, if you don't know how you're going to do data distribution, right, and that's a much bigger hole in your design than locking down the message queue broker configuration, right, to stop people connecting to it. So when I say security, I don't mean in the design sense. The design is full of security features, and we've thought about that a lot. I mean in the sense of making sure that everything has complete unit test coverage for all the different attacks you might want to think. And why not do that from the start? Because you know, if we have a design which is compelling, then you can sell people on paying for the next step, and if you don't, you can't.
And probably a follow-on question is the JVM, large attack service.
No, well, so part of the sandbox is vastly, I didn't even mention this, but you know, you won't have access to most of the standard library in there. And if you look at one of the things that's come up a lot when we talk to people who work with Ethereum is they say, well, you know, it's a tiny attack service, but it means we can't like do time and date calculations because there's no time and date library. So the the way you attack JVMs, right, is the bytecode language is sound. If once you pass bytecode verification, the only way to get out of that is exploiting bugs in the VM, right, or in the class library. So if you eliminate all of the native code, and you can, because you don't really need it for smart contract logic, then what you're left with is bugs that can cause non-determinism, and that's actually, I would say, the bigger problem than like attacks. If you look at the attacks that break out of the JVM, and I've done this, I've gone through all of them over a certain span of time, the way they all work is they find bugs in like user interface libraries and crypto libraries and stuff like that, but none of that stuff is necessary for smart contract logic. You can just ban it all, and we will. So we start with a production VM and then cut it down, rather than start with nothing and build up a VM from scratch, because doing it the way Ethereum did it means you have no debuggers, you have no good languages, you have no IDEs. They decided to reinvent all of that from scratch. They have weird performance issues because they use like 256-bit wide registers, and it makes much more sense to give people a development environment they're productive with and make it locked down. Yeah. In our view, of course, it's a perfectly reasonable thing to disagree.
So can I ask a really basic question?
And sorry, we'll get to this. Sorry.
You know, obviously you haven't decided to use just bit ledgers in the sense that they know now. Why that fundamental design decision?
Well, what, sorry?
Why that fundamental design decision?
Which, sorry, I didn't get
around
this.
distributed ledgers and how they're supposedly how the Bitcoin network works, how Ethereum works.
Oh, you mean why the UTXO model?
Yeah.
You can apply transactions in parallel. So if you think how do you implement like a global payment system on something like Ethereum, it implements a kind of like computer, right? You have what Ethereum calls smart contracts are not what Bitcoin calls smart contracts. An Ethereum contract is a stateful object floating in space, and they can do method calls on each other, and you've got basically like RPC basically between these objects. And as a result, if you had like one contract that was holding the balances of everyone who was holding dollars on this system, you would serialize everything into a single-threaded processing, right? Not only that, you could end up with a form of live lock in which everyone is attempting to update the same contract simultaneously, and like none of them get through. With the UTXO, I don't know why we call it the UTXO model in Bitcoin. Like the UTXO set is the set of all open states, right? And it's sort of the name of the model has ended up inheriting that name. You can construct and apply transactions in parallel, which obviously when there's no global broadcast, you don't even know someone else is applying a transaction, but they're all using cash. They're all using the same cash contract, for example. So there's scalability implications there. And there's a bunch of other reasons why we did it that way, but that's one of the main ones, yeah. The other thing is, I mean, if you've ever attempted to do programming in an adversarial environment with a pool of shared objects that talk to each other, it's really hard, as the DAO guys found out, right? They thought they were programming a single-threaded model, and they didn't know about reentrancy attacks, which is not a new problem, right? Reentrancy bugs have been around for a long, long time. They just didn't know about them, and then they got shot in the foot. But you Corda contracts like that, they don't call other contracts and things, so they're much simpler in a sense, and they don't have these issues. Yes, sir?
What's your transaction throughput and how much will it cost?
Yeah, so we don't know what the throughput is yet, because we haven't measured it. So that's when I said we will start load testing soon. It's going to be pretty low when we start, because again, we haven't measured it. We haven't optimized it, I should say. The bottleneck, sorry?
Can you give me a number?
Right now, I don't know, I would expect us to start with something in the hundreds per second and work up there. The bottleneck is the flow checkpointing. Yeah. So that can be optimized, you don't have to checkpoint every time you do. What you'll find, by the way, is there are companies and projects in this space that will quote very, very high numbers of transactions per second, because it's a simple metric everyone can understand. What they won't tell you is what happens if you kill the node halfway through, right? It's not, like, signature checking is fast. You can, a Bitcoin node can chew its way through a blockchain at like tens of thousands of transactions a second on like my laptop right? Because processing the signatures and even updating the database is fast. What kills you is constantly writing the state where you're up to disk. And it's the easiest thing in the world to gain these metrics by leaving that out and betting people won't ask, and you know what, they never do. They never ask.
And just pause on that, so what's your theoretical maximum, typically?
Theoretical max would be constrained by latency on the notaries. So, well, okay, so let's say you have a raft notary in which all the nodes are within the city, right? They're all peered at Telehouse London, they're within a millisecond of each other, they're running on nice, powerful hardware. You can chew through, I don't know, I'd imagine like tens of thousands, maybe even hundreds of thousands of transactions per second in this way. If you have everything, you know, perfectly optimized, nice multi-core machines, that's kind of the level of performance I would guess, but the Corda isn't designed for high-frequency trading, actually. Yeah, sure.
If you were to cite one or two worries about resilience of the Corda network, right? In
Mm-hmm.
terms of what can go wrong and what
Mm-hmm.
can lead to failure, what would your worries be?
The biggest worry of leading to failure. My worry would be that banks don't peer with each other, or they get the network engineering wrong, and the IP addresses of their nodes leak, and someone decides to dust them off the internet with a giant botnet. In terms of Corda itself, there aren't that many single points of failure. There are one or two in the co-design. There's a network map service, which tells you where institutions are on the network. But if that goes down, it just means you can't join new parties to the network for a while. It's not that big of a deal. And even that we plan to distribute. So the real risk is that your entire organization gets blasted off the internet, in my view. Sorry, I'm trying to keep this in order. I think you had your hand up first. Yeah.
How do you know that an output is spent?
Sorry?
How do you know that an output isn't spent?
That it isn't spent. Well, so in some cases, if it's an output you own, then you know it's not spent as long as you haven't signed for it. Right? If it's a shared ownership or it's someone else's output, then you have to go talk to the notary to find out for that state. The state itself points to a notary, and you can go say, in some cases, you can go find out if it's spent. Right? If you create a double spend, you can find that out. In other cases, you can't, because that would be a privacy leak. So it depends. It depends on the case, right? It depends on what the state is representing. If it's an asset, it's a bit different than if it's a deal. Sorry, you had a question.
I seem to remember, correct me if I'm wrong, that in the non-technical white paper that you
Mm-hmm.
mentioned oracles.
Mm-hmm.
Can you go into a bit more detail about how that aspect is, how you're dealing with that aspect?
Yeah. Yeah, so one of the apps in the repository is actually an interest rate swap.
Can you just repeat the question?
Oh, sorry, yes, sorry, I should repeat the questions. Question was oracles. What are we doing with oracles? How do they work in Corda? Those sort of it, right? Yeah. So you can go have a look at the code. So oracles are one of the things we implemented. So there's an app that does interest rate swap management in the code, and it has a few interesting features. One is it uses an oracle for the interest rates fixings. And the other is it shows state event scheduling. So one of the issues that came up when we talked to people who worked with Ethereum was like, you know, I can't react to time passing. And for things like fixing of a derivative contract, then you need to do that. And Corda has support for that built in. A state can advertise that it wants something to happen at a certain date, and then the vault looks at that and says, well, if this is my state, you know, if it's valid and it's mine and it's safe for me to do this, then the state can say, start this flow. So it can kick off a flow to do an update to the ledger. So the ledger can like keep itself up to date without you doing any programming in effect. The oracle there, the way it works is you put the oracle exposes two APIs in effect. One is give me the current interest rate that you think exists. And maybe you don't need that, maybe you already know. You just want this third party to sign. And then the second one is here's a transaction, and it has a command that contains the interest rate, or the state contains the interest rate. And then commands have public keys associated with them, and that's what defines who has to sign that transaction. So then you give the transaction to the oracle signs it, hands it back. Now you sign it, you send it to the other guy, and so on, and the oracle signs per transaction. Sometimes that's not what you want. Sometimes what you want is a third party to distribute data that it can be reused over and over again without that company being involved. And that's when you can use attachments. But for an oracle that tests something that constantly changes, like a stock price, you put it into the transaction, you give them the transaction, they sign it, they hand it to you back. And in fact, you can give them a part of the transaction, not the whole thing. Okay, so they only see what's relevant to them. Well, we'll come back to you. Yeah, sure.
Probably I'm jumping the gun because you said you're doing a bit of security there. And you did mention about privacy. I was just wondering if you had any implementation of ZKP into the Corda.
No, we don't. So I was having a conversation with Ellie Ben-Sasson actually just a few weeks ago. The reason we don't is the performance isn't there yet, right? For generic zero-knowledge proofs.
That's for snarks. You don't actually have to. I know really well.
Yeah, so
you can just do interactive ones. And you can actually get most of the things you want.
Yeah. So for things like proving that the transaction is valid without revealing the contents, I think you need the non-interactive one. But yeah, there may be places where we could use the interactive zero-knowledge proofs in parts of the protocol. We haven't done that yet. So I mentioned the sort of novel privacy research. That's not zero-knowledge proofs, but it's some stuff that can give similar benefits. So yeah, I hope to be able to give a separate presentation on that sometime. When we can pull the trigger on that. Yeah. But I would love to use them, by the way. I'm waiting for the PCP, trapdoorless version as well, which is probably a few years out. But it would take time for the people to build confidence in that crypto anyway. Yeah.
But also, you're not actually sharing the data with other parties.
You share it sometimes. Consider the case of a cache, right, which can potentially it's issued into existence by some bank, right? Maybe the central bank in the ideal case. It propagates around, it's involved in a bunch of deals. When you receive it, you have to verify all the way back to the issuance transaction. There are techniques you can use to fix that. Right? You can go reissue. You can just take the state to the issuer and say, give me a fresh one. And that's not atomic, of course, but as long as you trust the issuer to not get stuck halfway and forget about the request and things like that, then you can snip the chain that way. But yeah, and then for deals and things where it's just between a small number of parties, you don't have this like long chain problem either.
Does that imply that everything that happens from a coin that's issued is then tied to that coin through a chain of transactions?
It can be if you want them to be, if you want it to be atomic, right? So you can potentially have like a chain of payments that is never connected by transactions to like a chain of deals. In which case you lose the atomicity, which is a very nice property of these global ledgers. But you could do that, but it's designed such that you don't do that. It's designed such that you do, use cache and join them with these transactions. And then, there's anonymization of these technologies. You can do state reissue and so on, and then there's the other stuff we're researching as well. Well, implementing, I should say. Yeah?
How does it handle transaction privacies on the Vanguard question? Differently, to give two examples, the JP Morgan Quorum design and digital asset holdings global.
Yeah, I was on the JP Morgan call the other day. I mean, they're just. The question was how privacy. How do you handle that relative to, or like in comparison to Quorum and what was the other one, sir?
The GSL,
the digital assets, GSL. Yeah. So Quorum is actually somewhat similar to our design. Like there was a question at the end of that call yesterday. I don't know if you were on it. So they say what they do is they use Ethereum and then they give you private transactions where they encrypt the contents. And they publish the encrypted versions of the blockchain, and then you send the keys, and then those people decrypt. Now, they didn't mention this in their talk, but at the end, a very perceptive person asked a very straightforward question, which is what happens if the person you send it to needs to send that transaction onwards? And they were like, well, then you would give them the key as well. And I was like, oh, wait, that's exactly the same model the Corda uses, actually. Because they're just publishing the data waiting to be decrypted if anyone can factor those keys.
No, you can do proxy encryption if you want. Proxy re-encryption if you want.
Yeah, I mean, you can do that, but then why not just not distribute the data to start with, is the obvious question, right? Publishing it, even with very good encryption, giving people encrypted data and then saying, well, I'm not going to give you the key, or it is sometimes useful, if you're sending, for over-the-wire encryption and so on, but it's sort of, if you don't have to do it in the first place, and you don't, if you want to build a distributed ledger, right? They're using a Ethereum blockchain because they wanted to do something quickly, so they forked Ethereum. But it's not necessary to do that. Do we have any questions like around the back area? Because there are a lot of questions here in the front. Otherwise, no, we'll come back to you. No? Okay, yeah. Sorry? Last question. That's fair enough.
Is the transaction checkpointing potentially a resilience issue, or, is that a potential point of failure?
Well, the point, so the flow checkpointing is designed to prevent that kind of failure. What it means is the developer of the app...
You're relying on the databases to stay around, right?
You always do. Yeah. I'll just say a word on this just before we finish, because this has come up several times in the past few days, and I don't understand it at all. there's a common notion out there that if you use a blockchain or distributed ledger, you don't have to have backups anymore. So yeah, I've actually, along with Jim and Gary, we've actually built apps that went out and had millions of users, of non-technical Bitcoin users who move real money around with our apps. And even though if you back up your private key with Bitcoin wallets, you can at least get back your money if you lose your data, as long as you don't lose that private key. You lose all the metadata, right? Because all your notes, your labels, all the other stuff, and that's just for very simple, personal financial app, all goes. Good luck filling out your tax return if you lose that data. And so in reality, there is always private data that you want to join with the public data. And I guess any bank that doesn't have a working backup strategy is already dead by now. So Corda by itself, yeah, it assumes that you can keep a database around. It's not designed to allow you to lose everything and recover. And bluntly, neither is any other system, even if it might superficially appear otherwise.
Yeah, except with a true distributed ledger like Bitcoin, you have n copies at any time.
No, you have n copies of the public data, but that's almost never enough.